Let's take a look at another example using Gauss-Jordan elimination to solve a system of equations. This time we have a three-dimensional system, so our matrix will be a little bit bigger. The first thing that we want to do is translate our system of equations into an augmented matrix. So we're going to take the coefficients as well as the constraints. So I'm going to let the first column be x, the second column y, and the third column z. So if I read down the first column and looking at the coefficients, I should have a 1, a 2, and a -3. My second column, reading the coefficients, from the y terms, I should have a 1, a 3, and a 4. Reading down the third column, the z coefficients, we have a 2, a -1, a +1, and reading the constraints, we have 12, -2, and -8. So this is our initial augmented matrix. Now we're going to try to use Gauss-Jordan elimination. So our first goal is to have a 1 in the 1, 1 position, which is great because we already have that. Now that we have the 1 in the 1, 1 position, we need to pivot the first column. So we're pivoting on the 1 that is in the 1, 1 position. That means we're trying to make every other term in that column equal to 0. So, in order to change the second row, this is a 2, so I'm going to need -2 times row 1 plus row 2 in order to make row 2 have a 0 in the first position. Since our pivot element is always a 1, we will always be able to use the opposite value of the one we're trying to set to 0. That will always be your coefficient. The next column that we need to worry about is the bottom one. We have a -3, so we're going to need to take +3 times row 1 and add it to row 3. Okay. Now, you can do 2 row operations at once. That's perfectly fine. Just make sure that if you use the same row, so in this case row 1, we're always talking about row 1 as it is in this matrix. So if row 1 changed, I'm not going to use the changed version, I'm going to use the original version to do any matrix, any row operations. Okay, let's see. So you should practice doing this on the side right now. I'm not going to show the arithmetic between the 2 steps, so you should practice this on a scratch paper and then confirm that you get the right matrix. So you should pause the video right here and try it on your own and then come back. Okay, so let's see. After doing these row operations, we end up with the following matrix. We have a 1, 0, 0, a 1, 1, 7, a 2, -5, +7, and then a 12, -26, and a +28. This is now the next step that we want to use, the next matrix we want to use for our Gauss-Jordan elimination process. Since we've taken care of the first column, we now move on to the second column. So we're hoping for a 1 in the 2, 2 position. We have a 1 in the 2, 2 position, and so now we're going to pivot on the 1 that's in the 2, 2 position. So that means that we need to make everything else in this column equal to 0. So in order to eliminate the +1 from row 1, we're going to take -1 times row 2 and add it to row 1, and this will change row 1. We're using row 2 because row 2 is the row that has the pivot element. Just like before, row 1 had the pivot element, so we always had to use row 1 to change. Now we will always use row 2 because row 2 is the row with the pivot. So let's see, keeping that same idea, we need to eliminate the 7 from row 3, so we will do -7 row 2, that's my pivot, plus row 3. And this will go into row 3. So we're using row 2 to change all the other rows because that's the row with the pivot. So again, you should try these on the side and then compare them with the correct answer. So you should pause the video and try to work out the arithmetic for these row operations before going on to the next step. Okay, after doing the row operations, we end up with the following matrix. So we have a 1, 0, 0, 0, 1, 0, 7, negative 5, positive 42, 38, negative 26, and 210. Alright, so now we are hoping to have a 1 in the 3, 3 position. We don't have a 1 right here, so we're going to need to make a 1. So that means we need to turn 42 into a 1. And you can only do this by multiplying by a constant. So if I want to turn 42 into a 1, that means essentially that I want to divide by 42. So we want 1 over 42 times row 3. And this should only change row 3. So let's go ahead and figure out our next matrix. The first row should remain unchanged, since we haven't done anything to it. And the second row should also remain unchanged, since it had no changes made to it. 0 divided by 42 is still 0, so the first two entries are not changed. 42 divided by 42 is 1, and 210 divided by 42 is 5. So now we have a 1 in the 3, 3 position, and so we can go ahead and use row 3 in order to pivot on column 3. So we need to change the 7 and the negative 5 into zeros. So for the first row, since we're trying to eliminate a 7, we will use negative 7 row 3 plus row 1. And this is going to change row 1. For the second row, we have a negative 5 that we are trying to eliminate, so we will use a positive 5 row 3 plus row 2, and this will change row 2. Alright, so again, you should try the arithmetic here on your own on the side. Go ahead and pause the video and give that a shot. Okay, after the row operations, we should be left with the following matrix. We should have 1s on the diagonal, and the constraints, the constants, should be 3, negative 1, and positive 5. So we can read our solution. We started with original variables x, y, z, and so we need to use the same variables to read our solution. So this first column was representing x, the second column was y, and the third column was z. So we can say that since this is the first column, right, and there are no other entries in the first column, x is equal to 3. The next one is in the second column, and so y is equal to negative 1. And finally, this should be, these ones were written backwards. We should be diagonal, 0, 1. There we go. Finally, in the third position, we have a 1, and so we get z is equal to 5. So you could write your answer x, y, z, or if we want to write it as a coordinate pair, that would be 3, negative 1, 5, to write it as a point in 3 dimensions. Alright, that's it for now. Let me know if you have any questions.